Hello, chemists. Today we are going to be looking at predicting precipitation reactions. We're going to be working an ionic product prediction equation. Hopefully that'll give you a little bit more insight on how to approach these. The question we've got here is, will a precipitate of silver chloride form when 100 milliliters of 4.5 times 10 to the negative fourth mole per liter calcium chloride is mixed with 200 milliliters of 1.2 times 10 to the negative third mole per liter silver nitrate? And they tell us the K sub S of silver chloride. So first thing we want to do is we want to work out the ionic product and compare it to the K sub S. But we don't know the ionic product yet. We work out the ionic product by, since this is a type AB compound, we multiply the concentration of silver by the concentration of chloride. So first thing to do is work out the concentration of silver, work out the concentration of chloride. Start with chloride. Each mole of calcium chloride supplies 2 moles, because there's 2 chlorides for every calcium, of chloride before mixing, i.e. before we combine it with the silver nitrate, we have a concentration of 2 times the given concentration, because each mole of calcium chloride supplies 2 moles of chloride. So we put that concentration into our dilution factor equation, not forgetting to use the total volume of everything combined, and we get this here. Concentration of chlorine equals 100 divided by 300. That's the volume used. The SciPad calls it. I tend to use volume added. Volume added over total volume, i.e. both volumes put together, times the concentration of the original concentration, which is 2 times 4.5 to the negative fourth, and we get 3 times 10 to the negative fourth mole per liter as a concentration of chlorine. Okay, so hang on to that number. Moving on. We want to work out the concentration of silver. This is a little bit easier. Each mole of silver nitrate provides 1 mole of silver, so we don't need to do any multiplying there. We just know that before we mix, 1 mole of 1.2 times 10 to the negative fourth moles per liter of silver is present. Again, throw that into a dilution factor equation, and we get a total concentration of silver after combination of 8.0 times 10 to the negative fourth moles per liter. So now we have our 2 concentrations, our silver and our our silver and our chloride concentrations. Now we can work out the ionic product. To do that, we use the ionic product equation, which is pretty straightforward. You multiply the concentration of silver by the concentration of chloride. So 8.0 times 10 to the negative fourth times 3.0 times 10 to the negative fourth gives us 2.4 times 10 to the negative seventh. Take that number there, compare it to the K sub S that we were given on the first slide, and we can see that the ionic product, the thing we just calculated, is greater than the K sub S, because this exponent here, 10 to the negative seventh, is a less negative number than that one. That means that this is bigger. That means that the ionic product is greater than K sub S, therefore silver chloride will precipitate, i.e. if we did this reaction, if we combine these things together, we will get silver chloride precipitating out of solution until, i.e. the concentration of the silver chloride would decrease until the ionic product and the equilibrium product were the saturation product were the same. So the ionic product equals K sub S. That's it.